Introduction. Supervolcanoes are massive volcanic systems capable of producing extraordinary explosive eruptions that can have catastrophic effects on the environment and climate. Unlike typical volcanoes, which erupt relatively frequently and with moderate force, supervolcanoes can lie dormant for thousands of years before unleashing devastating eruptions. This article delves into the science behind supervolcanoes, their notable examples, and the potential impacts of their eruptions. What is a supervolcano? A supervolcano is defined by its ability to erupt with a volcanic eruption magnitude of 8 on the Volcanic Explosivity Index, VI. Such eruptions can release more than 1,000 cubic kilometers, 240 cubic miles, of material, including ash, gas, and rock. The characteristics of supervolcanoes include caldera formation. Supervolcanoes often create a large caldera, a depression formed when the land above a magma chamber collapses following a massive eruption. This caldera can range from several kilometers to tens of kilometers in diameter. Long dormancy. Many supervolcanoes can remain dormant for thousands of years. Their long periods of inactivity can make it difficult to predict when they will erupt again. Global impact. Eruptions from supervolcanoes can have severe global effects, including climate change, disruption of agriculture, and loss of life. Notable supervolcanoes. 1. Yellowstone caldera, USA. The Yellowstone caldera is perhaps the most famous supervolcano, located in Yellowstone National Park. It last erupted approximately 640,000 years ago, producing a massive ashfall that covered large portions of North America. Researchers estimate that the potential for future eruptions is significant, and ongoing geothermal activity indicates that the system remains active. Impact of eruption. A future eruption could release ash over vast areas, impacting air travel and agriculture while also contributing to climate changes akin to a volcanic winter. 2. Toba, Indonesia. The Toba supervolcano erupted about 74,000 years ago in what is considered one of the Earth's largest known volcanic eruptions. This eruption released an estimated 2,800 cubic kilometers, 670 cubic miles, of volcanic material, creating the Toba caldera. The eruption likely caused a volcanic winter that led to dramatic global temperature drops and significantly impacted human populations. Impact of eruption. Genetic studies suggest that the eruption may have led to a bottleneck in the human population, significantly reducing the number of surviving individuals. 3. Campi Flegrei, Italy. Located near Naples, Campi Flegrei, also known as the Phlegrean Fields, is an active supervolcano that has produced several major eruptions in the past, the most recent of which occurred around 40,000 years ago. The area is characterized by numerous craters, hot springs, and fumaroles, indicating ongoing volcanic activity. Impact of eruption. An eruption from Campi Flegrei could threaten nearby urban areas, affecting millions of people and potentially leading to widespread ashfall across Europe. 4. Taupo, New Zealand. The Taupo volcanic zone contains the Taupo supervolcano, which last erupted approximately 1,800 years ago. This eruption was one of the most significant in the last 5,000 years and resulted in the formation of Lake Taupo, the largest lake by surface area in New Zealand. Impact of eruption. Future eruptions could release ash and gases that would affect air quality and climate, not only in New Zealand but across the southern hemisphere. 5. Long Valley caldera, USA. Located in eastern California, the Long Valley caldera was formed by a massive eruption around 760,000 years ago. It has since shown signs of volcanic activity, including ground deformation and increased geothermal activity. Impact of eruption. A significant eruption could pose threats to air traffic and agriculture in the region, similar to other supervolcanic eruptions. Monitoring supervolcanoes. Scientists closely monitor supervolcanoes using various techniques, including ground deformation measurements, gas emissions analysis, and seismic activity detection. Organizations like the Yellowstone Volcano Observatory, and the U.S. Geological Survey, USGS, play critical roles in assessing volcanic hazards and developing evacuation plans. Conclusion: supervolcanoes represent one of nature's most powerful geological forces. Their eruptions can reshape landscapes, alter climates, and significantly impact human populations. Understanding supervolcanoes is vital for disaster preparedness and mitigating potential risks associated with future eruptions.